So these are the answers to these 10 problems that were up on the website. And I am going to go over the solutions to 1, 4, 9, and 10. But what I recommend you do is write these down or pause this or whatever you have to do and see if you can get these answers. Now, there are different ways to express your answer that might be correct, especially when you have a fraction, but you should be able to figure that out. If not, you can ask me about it in class. But pause this, see if you can get the answers. And then if you're having trouble again, you can come back and watch the rest of this video. I will go over 1, 4, 9, and 10. Okay, so here's number 1. 3x minus 4y equals 7, and you're asked to solve for x. So what I would do, if I were you, is move over every term that doesn't have an x in it as a first step. So this 4y, I would get rid of that. I would try to move that to the other side. How do I do that? How do I handle subtracting 4y? I would add 4y. Negative 4y plus 4y would be 0. So I end up with 3x minus 0, and I don't have to write minus 0 because it doesn't change the value, so it would just be 3x on this side. Since this is equal, in order to keep it equal, if I do one thing to the left side, I have to do the exact same thing to the right side. So I added 4y here. If I add 4y here, I keep these quantities equal. I keep the left side and the right side equal. So I have 3x equals 7 plus 4y. And now I want to get rid of this 3. Well, how do I move that 3 over? What do I do about multiplying by 3? I can divide by 3. 3 over 3 is not 0. 3 over 3 is 1. Any number divided by itself is 1. So I end up with 1 times x. I don't have to write 1 times x. I can just write x. It means the same thing. Whatever I do to one side, I have to do to the other side. So I'm going to divide this side by 3 also. And I get x equals 7 plus 4y over 3. And that is my answer. Now, let me rewrite this original problem here and show you why you might get something that looks different from this. What a lot of students do when they see a problem like this is they want to divide out the 3 first, and you can do that if you want, and you will get the right answer if you do the steps correctly at least. So let's take a look at this. Let's say you want to divide both sides by 3 first, because you're saying, hey, x is being multiplied by 3, so I know I have to get rid of that 3. May as well do it first. You can. But what you have to remember is that when you divide this 3x minus 4y by 3, you can't just divide this 3 into the 3x term. You have to divide it into both terms. You have to distribute it. It has to go into the 3x term and into this negative 4y term. So let me rewrite this. This 3x minus 4y over 3 is the same as this. So you can, this thing here, 3x over 3 minus 4y over 3 is exactly the same as 3x minus 4y over 3. Remember, when you're subtracting fractions, as long as they have a common denominator, you can just subtract the numerator times the numerator and put it all over the same denominator. So these are the same. So once you get to this point, sure, 3 over 3 is still 1, and I don't have to write 1 times x, so you end up with x minus 4/3 y equals 7/3. What do I do with this minus 4/3 y? In order to get x all by itself, I would add it to both sides. So minus 4/3 y plus 4/3 y, that's 0. And I don't have to write x minus 0, I can just write x. But if I do it to the left side, I have to do it to the right side. And so what do I end up with? I end up with x equals 7/3 plus 4/3 y. And you might look at this and you might say, wait a minute, 7 plus 4y over 3 is not the same as 7/3 plus 4/3 times y, but in fact it is. These are the same. Remember that 4/3 y, let me write that up here. 4/3 y is the same as 4y over 3. This is the same thing. It's a slightly different way to write it. But when you have the y here multiplied by this fraction, 4 over 3, that y just really gets multiplied by the numerator. So you can write it as 4y over 3. It's the same thing. So these are the same, this is the same answer. So you could have written it either way and it would be correct. Now we'll do number 4. So here is number 4. You're asked to solve for y. Let me rewrite this first. 3/5 y plus a equals b, and you want to get this y by itself. The first thing I would recommend doing is getting rid of every term that doesn't have a y in it. In this case, that's just this plus a. What do I do about adding a? I can subtract a. A minus a is 0. So I end up with 3/5 y plus 0, and I don't have to write plus 0. If I subtract a from this side, I have to do the same thing to the other side, otherwise I won't keep this equal. So I have 3/5 y equals b minus a, and I want to get y by itself. Well, what do I do about multiplying by 3/5? You can divide by 3/5. And that would be 1, but then you would end up with b minus a divided by 3 divided by 5, and I think that's kind of a messy, and we could simplify that, but there's an easier way to do this. If you want to get this to be 1, you want to end up with 1 times y, you can multiply by the reciprocal. So you can multiply, you can flip this fraction, 3/5, the reciprocal would be 5/3. And when you multiply fractions, remember it's numerator times numerator, 5 times 3, divided by denominator times denominator, 3 times 5. Well, 5 times 3 is 15, 3 times 5 is 15. You end up with 15/15, and that is 1. So I end up with 1 times y, which I can rewrite as just y. Whatever I do to this side, I multiplied this side by 5/3, so I have to multiply this side by 5/3. And you'll notice that I put this b minus a in parentheses, and that's to remind me that this 5/3 has to be multiplied by the entire right side of the equation. I can't just multiply it by the b. Let me show you what I mean. What a lot of students will write as their solution is this, and this is not right. This is showing that the 5/3 is just being multiplied by the b, but you can't. You have to multiply it by the entire right side of the equation. So make sure that you show that you're doing that. You can just use parentheses. If you wanted to, you could distribute that 5/3. You could multiply it by both terms. So what would that look like? You could also write y equals 5/3 b, right? You multiply the 5/3 by the b, minus, you got to keep that negative sign, 5/3 a. And that would be correct also. So either one of these are the same. Now we'll do number 9. Here's number 9. You have p times quantity t plus 1 equals -2. One thing I would caution you about that is can be problematic is your handwriting. If you have really bad handwriting, or if you try to solve these problems using as little, the smallest area of the paper possible, you can lose track of negative signs. So make sure, if you want to save trees, plant one, but don't write little tiny things on your homework paper. It can be hard for me to read, and more importantly, hard for you to read. So this is p times quantity t plus 1 is -2. You want to solve for t. What a lot of students will do when they see that you have this p outside the parentheses is distribute it. You'll multiply it by the t and by the 1. But in this case, bear in mind what you're trying to do. You want this t by itself. So why would I complicate things? Why would I multiply it by a p when I don't have to? So this is just showing that p, whatever p is multiplied by some term in parentheses, and it doesn't matter what's inside the parentheses. This is just a product, p times something. So if I have p times something on this side, the way to get rid of that is to divide by p. And whatever I do to one side, I have to do to the other. So I end up with p times whatever this term is over p, and p over p is 1. So I don't have to write that. I don't have to write 1 times t plus 1. It's just t plus 1 that I'm left with on this side. And this is -2 over p. So how do I get rid of plus 1? I subtract. So let's subtract 1 from both sides. 1 minus 1 is 0. I end up with t plus 0. I don't have to write that 0. So I end up with t equals -2 over p minus 1. Now, a word of caution and a mistake that's not uncommon for students to make is there is a difference between -2 over p minus 1. This does not equal -2 minus 1 over p. These are not the same thing. And if you're not sure, if you don't remember all your math rules, you can always make up a number and plug it in and see if this would still be equal. So let's make up a number for p. Let's say p equals 2. Try not to, when you pick a random number, make it 1, because sometimes things will look like they're equal when they're really not. But let's pick 2. So we have, on this left side of the equation, if I say p is 2, we have negative 2 over 2 minus 1. Negative 2 over 2 is negative 1. Negative 1 minus 1 is negative 2. So that's what that would equal. Now let's go on this side of the equation. I would have negative 2 minus 1 over 2. Negative 2 minus 1 is negative 3. Negative 3 halves. And so we see that these things are not equal. So just be careful about how you write these things. Remember, you're subtracting. When we go back to this step, you're subtracting 1 from this whole side of the equal sign. You're subtracting it from the fraction, not just from the numerator of the fraction. And I will do number 10. Here is number 10, 3ax minus n over 5, and your equals negative 4. And you're solving for x. So the first thing I would do is get rid of that dividing by 5. We want to get x by itself. So we're going to move things over one at a time till x is by itself. First thing I'm going to do is get rid of dividing by 5. How do I get rid of dividing by 5? I'm going to multiply by 5. I'm going to write 5 over 1 so you don't get screwed up. So I'm going to multiply the 5 by this entire side of the equal sign, this whole 3ax minus n over 5. So that's what the parentheses are for, is to remind us that we're doing this. When you multiply, it's 5 over 1. It would really just be times this numerator. So you would end up, let me write it here, with 5 times 3ax minus n over 5. This is what happens when I multiply by 5 over 1. Remember, when you have some number times something in parentheses, and that's all there is, you can treat this, whatever's in parentheses is just some term you're multiplying by. So I have 5 times something over 5. These 5s, 5 over 5 is 1. So on this side, I end up with just 3ax minus n. But if I multiply this side by 5, I have to multiply the other side by 5. And negative 4 times 5 is negative 20. So let me rewrite this. I've kind of messed this up a little bit. 3ax minus n is negative 20. So just watch your algebraic signs here. It's easy to, again, drop a negative sign or forget about it, especially if your handwriting is bad. So I want x by itself. How do I get rid of subtracting n? I'm going to add it to both sides. Negative n plus n is 0. So I end up with 3ax minus 0, and I don't have to write that. But whatever I do to one side, I have to do to the other. 3ax equals negative 20 plus n, or n minus 20. You could also write this as n minus 20. It would be the same thing. So I'm almost there. I want x by itself. How do I get rid of multiplying by 3a? I divide by 3a. Whatever I do to one side, I have to do to the other. 3a over 3a is 1. So I'm left with 1 times x, and I don't have to write that x. And then I have this negative 20 plus n over 3a. I'm going to write the answer up here because I've made a mess down here. And so I have x equals negative 20 plus n divided by 3a. And that is the answer. So go over the rest of these. If you have any questions, bring them to class and we'll go over them.